Hello and welcome to another Teaching Mathematics webinar. Welcome, Craig. It's good to have you back again.
Thank you, Helen. It's good to be back.
It's good to have you. Now I'm a little distracted because I just saw on our opening intro it said teaching grade 12 mathematics, and of course we're not talking about teaching grade 12. Otherwise we're in a bit of trouble, aren't we?
Well, yeah, I'm here for grade 10 today.
Yes.
So can we agree on that one?
Yes, we are definitely here to talk about grade 10 financial maths. And then we've got Dylan behind the buttons. Now, another thing I noticed is that in the competitions video we were just watching, it told us that you could win 55 rands airtime. Of course, you can't win 55 rands airtime. It's 2 times that amount. Maths teacher, what is 2 times 55?
110?
Well done. So we are giving away 110 rands worth of Vodacom airtime if you talk to us on Twitter or on Facebook. Of course, not everyone who talks to us will win, but you do stand a chance if you are talking. Another thing you can win, seeing as we're talking about competitions, is a phone or a tablet. And they're good phones and good tablets. It's not like a Nokia 3310, which was a good phone. I think mine is still working. But it's a Sony Xperia L as well as a Samsung Galaxy tablet. So it's good stuff. If you would like to win these prizes, all you need to do is watch out for the secret code that will appear at the bottom of the screen at some point during the show. Write it down and then send us a teaching resource which has worked well for you in your classroom. We'll collate them and we'll put them up so that everyone can use them. So be warned, watch out for spelling errors because once it's on there, it's going to be on the website. But we're really excited to see what people are doing in their classroom. It doesn't only have to be a worksheet. It could be anything. It could actually even be a video of you doing an activity in your classroom. It's an exciting competition. Yes, because there are good things happening in the classrooms in South Africa, aren't there?
They are.
Yes. Okay, I feel like I've given a big speech. Why don't you tell us a little bit about yourself?
I work at Wits University. I am currently involved in teacher education, in-service teacher education in a research and development project. But one of the things that really pushes my buttons in terms of this session is the financial math stuff, because my PhD was in teachers' knowledge for financial mathematics. And so it's something I've given a lot of thought to.
Yes.
And thought about for a long time, because a PhD journey is a long one. So I'm looking forward to it.
I have heard rumors. Personally, I've not done a PhD, nor do I ever see myself doing one.
Not just about us teaching mathematics to learners, but also learning about these things ourselves.
Yeah.
And realizing how little attention has been given to financial maths and the learning of it across the world. And in fact, one of the things I discovered is that South Africa is one of the few countries in the world that has financial maths in the curriculum to the level that we have. So not in the UK, not in the US, not in Australia, as far as I know.
So we're actually winning.
So we're winning the game here.
Oh, good. Well, that's positive news for maths teachers. We don't get much these days. I had a conversation with someone recently, someone whose opinion I respect in terms of their mathematical knowledge and things like that. And they said they don't understand why financial maths is actually in the syllabus because it doesn't really fit anywhere. What are your thoughts?
Well, my assumption is that financial maths came into the curriculum because of the move with Curriculum 2005 to have an education and a mathematics education that is more relevant to what we had before. And I think that's good. Unfortunately, what came to be financial maths in the school curriculum, I think for many learners and for teachers, is here's a formula, plug some stuff in, hit your calculator and get an answer out.
Yes.
And so the really interesting stuff about financial maths we don't get to. And some of that is because the most interesting stuff is in grade 12. The grade 12 financial maths curriculum is really, really overloaded in terms of content. And so there just isn't time to get into the interesting stuff. And so I can, at one level, understand why someone says, what's it there for? Because it's not really functioning that well. But if it's not there at all, it could never function well. And I think we have to make it work. I think that we need to be talking to policymakers and curriculum developers and saying, we can do this better.
Yeah.
And I think there's opportunity to do that. And maybe in the next curriculum, we've got it. There could be some change. And I want to talk about some of what I see as a problem in grade 10. Because, grade 10 there's a great Afrikaans word, droog. It just doesn't do anything in the financial maths section.
Yeah. Yes. I had a thought I wanted to follow that up with, but it's escaped me quickly. Before I forget, if you have any comments to make on this topic, please use the hashtag MEMATS. That's the letter M, the letter E, and then the word maths after that. That's, of course, if you're on Twitter. And to talk to us on the Facebook, not the Facebook. To talk to us on Facebook, you need to find our Facebook page, which is the Digital Classroom South Africa page, and then make posts over there. Okay. Now, Craig, as you know, we've been reading this book called Teach Like a Champion, and we've been going through the techniques one by one. Last week, for those of you who watched last week, you know that that step really rubbed me up the wrong way. This one's more interesting, and it's step number 12, or about the material, and puts it out front. Now, when I've taught financial maths in the past, I'm going to do a brief demonstration of how I've done it, because I don't think I'm alone in the way that I've introduced it. Stand up there, I say, right, kids, this is a section you can get 100 marks for. You've got two formulae, this one, and this one has it in the exponent, this one doesn't, and you put the numbers in here, here, here.
Then perhaps. But certainly that wasn't why it was put in the curriculum. Of that I am sure. But yeah, I think the other thing that's important for us to understand is that in order to teach financial maths in an engaging way, teachers need a whole lot more knowledge than mathematics. They need to understand things about how the banks work, and where do you get that? It's really not easy to find out there. And I mean, having done the PhD, I've kind of realization that you would need in order to teach some of these things. And perhaps if there's time, we can talk about one or two of them as we go along.
A quick question based on that. I've always wondered if the formulae we use, the compound interest and the simple interest, are actually accurate. Is it the same that's used within the banks? Or is it a simplified version?
It's simple. I love that question, because I have an answer, because I've thought about it so much. The way the banks work actually is that they calculate interest every day, but they don't compound it until the end of the month.
Okay.
So you get a little bit each day, but no more on the interest. So the interest is kind of like sitting somewhere else. And the interest accumulates in one pot, if you want.
Yes.
And at the end of the month, the way I think about it is that pot gets tipped into the account.
Yes.
And that's the compounding, where the interest gets added into the account, and they're interested to see whether the compound interest formula really does give us a good answer. And so I spend quite a lot of time fiddling on spreadsheets and trying to do it the way the bank does it. And based on my calculations, it comes out to be very, very accurate and very, very efficient. Explain this, because it might be useful for teachers to take a look at.
And then I'll put it in the blog. So if you would like to see that, you're welcome to go to the blog and click on that link.
Yeah. Sure.
Yes. Okay, now we're going to start with looking at what's said in the CAPS document. And Dylan, we have a slide for this. I'm not sure how such as profit, loss, discount, and VAT, budgets, accounts and loans, simple interest and hire purchase, exchange rates and commission, rentals, compound interest. And the grade 10 one says, use the simple and compound growth formulae, P in brackets 1 plus I to the power of n, to solve problems including annual interest, hire purchase, inflation, population growth, and other real-life problems. Understand the implications of fluctuating foreign exchange rates, e.g. on the petrol price, imports.
But actually, there's not a lot of substance. And so the emphasis there is kind of understanding stuff about profit and loss and rental and hire purchase. It doesn't focus on actual simple and compound interest. And while I think that's a good thing, I think that there's not enough attention that's been given to simple and compound interest there.
Okay.
And so, although it can get a bit lost there, is where it says in the grade 10 one, to solve problems including annual interest, which works on the assumption then that we're only working with scenarios where we compound interest annually and not more frequently. And that only comes in grade 11, which I think is silly, frankly, because in maths literacy, the more frequent compounding periods across the two curricula.
Yes, it also feels a bit strange that when you're teaching it, that you teach annually 1 year and then the next year you say, oh, but hold on a second, we can now change this to suit another method. Yeah. And if you are teaching a plug-and-play type or plug-and-chug type method of teaching and suddenly you're throwing in periods, I used to divide.
And so the assumption is that it's compounded monthly. If it's not stated, then you assume monthly compounding. Whereas in textbooks, if it's not stated, you assume annual compounding.
Yes.
And that's an important difference for teachers to be aware of, that, there's two different things going on here. And I'm sure it's simply because we've started off with annual compounding, and we've done it for so long that it just has become the norm, and we have to specify that it's no longer the norm.
Yeah.
But
start with my communications today. Now, you've set up a list of good ideas.
okay.
So let's take a look at those. And the first one says, I'll let you read that.
Multiplicative approach for percentage. That's a big fat word.
Yes, it is.
I mean, one of the things that's really important with percentage
Refers to multiplication.
Absolutely, yeah.
Yes. Yeah. Okay. The next one, pay attention to language of financial maths.
I know that many teachers and many learners have said, particularly those who are working in a second or third language, saying that one of the things they find difficult with financial maths is that there's just more words. And so it becomes a word problem, albeit of a different kind, because it's fairly predictable. But it's still a word problem nevertheless. And I want to illustrate
language, and now they must use both of those.
Absolutely.
Yes. The third point, link with grade 10 functions.
This gets to the comment I made earlier about grade 10 financial maths doesn't seem to really build much on grade 9 or go anywhere. And I want to offer some suggestions in terms of how I think we can connect it to other aspects of the grade 10 curriculum. Because I think that you can use the finance to understand linear growth and exponential growth more easily, and you can use linear growth to explain what's going on with finance. So I think that they can support each other.
Well, I have read a couple of things that say when you create links like that, you strengthen the knowledge on both sides. Yeah, so it makes sense to do as many links as possible. Bridge gap to grade 11 financial maths.
Again, I mean, given that we're going to get the curriculum changed and move the stuff down, one of the things in looking at linear and exponential growth is then to push onto, in grade 11, learners are going to encounter depreciation, and there's two kinds that the curriculum covers. And so I'm hoping that by doing some of these, and so that's kind of where I'm wanting to look at ways in which we can push the grade 10 curriculum towards the grade 11 curriculum without actually teaching the grade 11 stuff in grade 10.
It's often difficult if you are only teaching grade 10 to see where things are going in grade 11. So it's worthwhile seeing what's happening in the future. The last point says, encourage learners to engage with real world of banking.
And that point, I'm getting back to some of the things that are in the curriculum document. Now, frankly, there's a list of things in that curriculum document, and I kind of wonder whether the average 15 and 16-year-old is particularly interested in them. The petrol price, exchange rate, it doesn't affect many of their lives.
No.
And that's not to say that they shouldn't be engaging with the financial world. And even if it's just going to banks, understanding what products are available for saving money, for borrowing money when they're older, what kind of accounts are available to teenagers and to students, because they're different products that are available. Just looking for those opportunities. For those who have access to the internet, you can Google the banks and go onto their websites. You can see what's there, what interest rates they offer. Just becoming, for many kids, particularly those who are growing up in working class homes, they don't easily have access to that. And so it's important for them to take that initiative themselves, and for us as teachers and teacher educators to encourage them to do that.
I think up until recently, a large amount of South Africans, or large group of South Africans, didn't have access to banks at all.
Absolutely, yeah.
And now suddenly we've got banks that do cater for the average South African, and it is more accessible.
It is more accessible, and there are life skills involved there. And as we said, the curriculum doesn't necessarily prepare you for those financial life skills, but I think by encouraging our learners to start looking at and asking those questions.
Pay my home loan. I don't know how
we
it's
didn't go
calculated.
into teaching for the money, the majority of us, and so finance is not necessarily the stuff that pushes our buttons.
Yeah.
But if in order to understand it for ourselves and to teach it well, that additional knowledge is really important.
Yeah. And at least know your own bank account, so you can talk from your own experience. Yeah. Yes. Okay. Where we're going next are the 4 pressure points. And the 4 pressure points are basically points where either teachers go wrong or students go wrong, and you've put them to poor understanding of percentage. Do you want to add anything
Well,
at this
just
point?
to say that, we've talked about it earlier. Percentage is a really, really difficult concept. And many learners beyond GET, so grade 10, 11, 12, and adults struggle with percentage. And there is research evidence across the world. School, not knowing percentage that well as well, based on what we see. And so we, even at grade 10 level, we shouldn't take it for granted. And I'm going to put some examples up just now that are going to get us to have to think quite carefully about our understanding of percentage. It's a really tough one, and I think we need to... It's not our learners who are thick. It's not us as teachers who can't teach it, maybe. It's a mathematical concept that's really hard.
Yes, Dylan.
Is that at all related to struggles that people tend to have with fractions? Is it part of the same family?
It is, because
same roots?
fractions, or common fractions, decimals, ratio, proportion, percentage, they're all connected. And I mean, ratio as well is such a key concept in financial maths. When we talk about indicators, you hear on the news about different indicators have gone up a certain number of points and stuff like that. That's all based on ratios. So much of financial maths in the banking world is about ratio and percentage. And, you know, it's stuff that we really battle with, and it goes back to primary school.
Yes.
So, and we're going to sit with it in grade 10 and 11 as well, and we need to accept it. We can't pretend that it's not there. Hence, I'd like to talk a bit more about it.
Yes.
Can I ask
Dylan.
one further quick question, and maybe don't answer it now, but perhaps through the course of the rest of the show. Is this section on financial maths kind of, maybe we need to take it a little bit more seriously because it's, well, let me put it this way, is it one of the underpinnings of some of the skills we want learners to leave so that they have the wherewithal to hopefully start their own businesses, have that sense of how money works, and at a fairly deep, almost intuitive level, so that when they do leave school, they're not having to look for someone else to employ them. They can actually start to create value in the economy themselves?
Oh, Dylan, you've opened a can of worms, and I want to jump in here. I'm sorry, I know you are the expert, but occasionally I get very passionate about some of the stuff that's happening in MathsLit, and I would say that's MathsLit's strength, is that they teach about money coming in and money going out, so people can leave knowing how to manage a budget. This financial maths, it's not really about budgeting at all. It's about calculating interest on a home loan. So in my opinion, we're training our maths students to become employees and our maths literacy students to become employers. Yes. Okay. Now, maybe you want to comment on that. Maybe you think I'm talking rubbish. Use the hashtag MEMaths. And now to you, Craig. Do you have any comments on that?
Well, I mean, the answer to Dylan's question is a huge yes, in the sense of that's what we want to do. But we also need to appreciate the pressure on maths teachers. There's a curriculum to cover. Financial maths is 15% of the curriculum from grade 10 or 11 or 12. It's not a big section at all. And so we've got to, we've kind of got to bear that in mind. And then we also need to think, maths teachers trained as maths teachers. They didn't train as financial advisors. Or,
yes.
They don't have BCom degrees in most cases. And so where do they get this knowledge to help learners? And so, while it's desirable to have that, the average math teacher doesn't come automatically with a whole lot of financial background. And, I mean, I've heard math teachers saying, this is not my job, this is the EMS teacher's job.
Yes.
Or the accounting teacher's job. And so I think there is a fine line sometimes between the two. But yeah, if we want people to become entrepreneurs and we want people to have a good sense of financial literacy.
Greg gets 20 Rand for her birthday. It should be in the context of starting your own business. Yeah, you need so much money. But then if you're taking out a loan, that's grade 12 content, isn't it?
It is. And that's one of the difficulties, that most interesting stuff is in grade 12 when there's least time to kind of take a bit of, a bit of a gap and really get passionate about this stuff. So hence we've got to win this battle. We've got to get some of the stuff down, so we've got more space in matric.
Yes, I think so. Okay, your next point says rounding errors, and then after that, identifying whether scenario involves simple or compound growth.
So with regard to the rounding errors, I think this is stuff that we kind of all know. When you round off and then you use you use that number in another calculation, you're losing some of the detail of it. And when you're working with decimal points, and sometimes up to 3 or 4 decimal places in financial maths, if you keep rounding off as you're going along, your final answer could be substantially different to what it should be. And so learners, when they're using calculators, in most cases they will be, need to be clear that they shouldn't be rounding off at all until the end. And I think that those who are doing step-by-step calculations often tend to write it to it's finance. We work to 2 decimal places, and so it makes sense there's a reason to round in this particular context. So but it's something that as teachers and as learners we all need to be attentive to and realize the impact of it.
Round off
till the end. Yep, not till the end. In terms of whether scenarios involve simple or compound growth, in the finance context, it's generally pretty obvious because they kind of say to you, it's earning simple interest or compound interest. I mean, then it's, compound growth. But clearly, it's built, if a tree is growing 10% of its height each year, we're not going to go back to its original height and grow 10%. We're growing it on the previous year's growth. And so it's appreciating that an example like salary increase. So it's not, the finance gives it away, but it's when it's non-financial. Population is clearly exponential. It's growing on last year's population. And so, that's the point I was trying to make there.
Okay. Now, the next slide, we're going to a few second language speakers who were teaching mathematics. And often, when the exams were set and we were all writing out our own memos, we would get different answers for the financial maths questions because, as we know as South Africans, now and right now.
Our listeners can see at the moment. I've taken a really simple example. So I invest 600 Rand at 9% per annum. That's actually relevant to my point here. How much will accumulate in 5 years, after 5 years, at the end of 5 years, over 5 years? In the context of financial, in the 5th year has an in, so does the first one, in 5 years, but they are different. In 5 years is referring to a 5-year period.
Yes.
In the 5th year is referring to the last year, which is a 1-year period. And all these things, and they all relate to prepositions in many cases. It's the prepositions that are really difficult, particularly as a second or third language speaker. And so this is just one example where I think we need to be really attentive to helping learners decode, but also when we're setting exam questions, I think to be explicit. If we are not testing their interpretation of the time frame, then don't leave it up to chance. Make it explicit. So in which case, I would say at the end of 5 years, where I think it's pretty clear what's required. But, there are times when I think we all need to recognize what different words can mean the same thing in this context. And it's about context matters here, because the word in a different context would not mean the same. And, for example, in and after wouldn't be the same. So it's just a simple example to try and just foreground the need to pay attention to the language.
Now, I think in questions like this, where wording does play such a huge role, it's important to get another teacher to do the problem.
Absolutely.
To see if it's been interpreted in the right way.
Yeah, absolutely.
Yeah. Okay, the next thing we're going to look at are the percentages. Yes, a pair of shoes cost 500 Rand excluding VAT. What is the price including VAT? That's a very typical question.
That's very typical, and so it's not very exciting, I guess. Hey, but my point here is not so much the question, but to look at the multiplication and the percentages that are going on. So if we could just get the next part of the slide up. What I've called there an additive approach. You've got 500 Rand, which is the price, plus 500 times 0.14, which is the VAT. 14% VAT converted to decimal. Add them together, you get 570. So that's the additive where you've separated the initial amount, the price of the shoes, excluding VAT, from calculating the VAT. The next part of the slide is what I've called the multiplicative approach.
And that's the big word we had earlier.
And that's the big word from earlier. And there, although there's an addition in the bracket, the issue is really that 1.14 that we see in the second line. It's what I call the growth factor. It's the thing you're multiplying 500 by that's going to grow it to this new amount.
Okay.
And so it includes the one on the left-hand side, the whole number part is the 500.
Yes.
And the 0.14, the comma 14, is the decimal part, which is the VAT. Yeah. And so we get the same answer. But it's understanding that I can take 500 and multiply by 1.14. And certainly the research that's been done in the UK, they suggest that that's a key part of understanding multiplicative relationships and ultimately understanding interest. And so shifting from the additive to the multiplicative approach seems to be an important thing to do. And in fact, this would be grade 7, 8, 9 before grade 10. But I think it's something for grade 10 teachers to really think about and push their learners to think about. Because in the next slide, we'll see how much more elegant
I want
it
to
is.
just spend a little bit more time.
Come back.
There we go. I know when I was teaching grade 9, we did the additive approach, and then in the next year we would switch over to the approach. And it confused me. Why do we teach one method and then teach the other method? And your research is showing that we should just rather stick to the multiplication.
It's not my research, by the way. But
okay.
I think the additive approach makes sense. Okay, we've got this thing, then we've got this amount, then we're going to calculate the interest on it, or the VAT on it, or whatever portion is we're going to calculate on it. Could be discount. And if you think about factorizing, if you look at the additive approach, if you factor, or the multiplicative approach rather, if you factorize out the 500, you end up with 1 plus 0.14.
Yes.
So that's the distributive law working in reverse here, where we factorize it out. So grade 9 learners do the distributive law.
Yes.
And so I think that in grade 9 it would be an appropriate thing to be showing we can do it this way or we can do it the multiplicative way. And here's how this relates to other mathematics we're doing in grade 9 or grade 10. I think that's where I would...
I think they might actually take out common factors in grade 9 as well.
Definitely. Yeah.
So you could actually link the two, and they're, creating those bridges, strengthening both concepts. Okay, thank you. I'm ready to move on to the next slide.
So in the next slide, I just chose a context about school fees. And I did that deliberately because I didn't want to explicitly say whether this is simple or compound growth.
Okay.
So as an example of what I was mentioning earlier. But I mean, clearly school fees, if they increase each year, they increase on last year's fees. And so it is a compounding scenario.
Yes.
Where the new amount is based on the immediate previous one. So, and these are a bit of a thumbsuck in terms of numbers. Some people pay far less in school fees. Some people have free schooling. Some people pay much more. But as in many financial maths problems, you just choose numbers that work nicely.
Yes.
Which, of course, is what you said we probably shouldn't do. Okay, so I chose 7.5%, which I think is probably quite steep in terms of an increase for fees each year, but nevertheless. So I've tried to color code here and illustrate what I was saying in the previous slide. 2014 is the 4,000 Rand. Okay, that's the school fees for this year. And then in 2015, we're increasing it by 7.5%, which is which would be 0.075.
Yes.
And I've put a factor in there of 1.075 to get this multiplicative idea.
Yes.
Which I was talking about earlier. So when we multiply 4,000 by 1.075, we get 4,300.
Yes.
Now I've taken that into the next line for 2016, again multiplied it by the same factor, and I get the blue.
Okay.
Again multiplied it in 2017 by the same factor, and I get 4,969 Rand and 19 cents.
I really like the color coding you've used. I can see immediately that the 2015 price is going to be 4,300 rather than looking at the calculations.
And so the output of the 1 year becomes the input.
Yes.
Of the next year. And that's a useful way of thinking about the compounding as well. Okay, so we can see now that every year we're multiplying by this factor. And we don't have this plus and these two pieces. Now, in the next part of the slide...
Don't hold that thought. So the color coding in terms of writing problems on the board is really important,
yes,
actually.
Agreed. I love that, yes.
Because then, as a student, you can go and you can see that this, the amount we're paying is that amount over there, and this over here is used to calculate that amount, but we're using from there to get that.
And just kind of, often circling the thing and drawing an arrow to where it's moved. I think those things are really helpful techniques on the board.
Yes.
When you're finished, yep. Good idea.
Be colourful. Okay, thank you.
So what I try to do now in this last thing is so the fees in 2017, and I've tried to use the colours from above. It's 4,000, which is the fees in 2014, right?
Mm-hmm.
Times that brownie colour, and that together, those two numbers, in other words, those are factors, right? Multiply those two together. That gives me the amount for 2015.
Yes.
If I multiply by the blue factor, I've got the school fees for 2016. And if I multiply all of that by the green factor, I've got the school fees for 2017. So if we think we are putting, I don't want to say the word adding because we're not adding, but we are putting another factor next to it as we move from left to right. And in fact, and the operation we're performing is multiplication, obviously. Now, if we think of those three factors and think of exponents, we've got one factor multiplied by itself 3 times.
Yes.
And so in that second row, I've got 1,075 to the power of 3.
Yes.
And that, I think, starts to kind of say, hang on, this looks like the compound interest formula. We've got the principal amount, the 4,000, the interest thingy in the bracket, we'll come to that now, and then the exponent, which is the number of times it's compounded. And that will give me the same amount as the green number in the top box.
Yeah.
So what I was trying to illustrate there is how that multiplicative approach with percentages moves us quite smoothly into the compound interest formula.
It does.
Rather than the bitty additive approach. And that's why I think it's worth investing the time on the multiplicative approach and learning to say the word.
Yeah. Next year. I'll put it on my list.
Okay, you do that.
Yes.
I think it helped because, in a sense, the compound interest formula kind of popped out. Because it's not a big step now to say, well, if we did this 10 times, what would the exponent be? If we did this n times, what would the exponent be? And so I think it's, without deriving the formula in a formal sense, we're getting an illustration of where the formula comes from.
Yes.
And I think that that's useful.
Now, I'm slowly catching on to what you're saying. In my past life as a teacher, what I would do is I would have the table of how something grew in simple interest, and next to it the same table in compound interest, and then I would say, look, this one's bigger than that one. Here's the formula to calculate it. And it hasn't drawn the line nicely as that has, your example over there, where you're multiplying by the interest thingy, as you put it over
interest
and over
factor,
again.
Yeah.
Yes.
The factor. I think that the compound interest formula is a really elegant formula. And I think it's much more complex than we really realize. And I know that every time I'm going into class to derive it and to do a formal derivation, I go and practice it beforehand because I'm embarrassed to tell you how many times I've got it wrong because I've gone off on something and done something and I've messed it up. And it's kind of because it looks so simple at the end.
Yes.
I think it's seductive that we think it's so easy. And let me speak for myself, but I have messed it up way too many times. And so now I practice it the night before or the morning before I ever go in to do the derivation. It doesn't matter how many times
we
I
need
do
to
it.
practice.
I've burnt my fingers too many times.
Okay, shall we go on to the next slide? Yes.
Okay, so I think we need to move quickly through this one. So you're going to hate this. A bag costs 300 Rand. Now, for some people, that's a cheap bag, and for some people, that's an incredibly expensive bag. And if my daughter paid that money for it, it better be her own. But nevertheless, what I'm really trying to get at here is those 3 different examples of questions which push us to think very carefully about percentage. So let's just take this. I'm going to take the second one in the interest of time because there's fewer words. So if there's a 10% discount on that price and then a 10% increase, is the price going to end up back at 300 Rand? Because our gut feel says it should, right? You've taken off 10, you've added on 10, should end up where it started. Because if you subtract 10 and you add 10, it will end up back at 300. And of course, those of us who've done these a few times and got them wrong before will know that in fact it's not going to end up at 300. And I think we're going to leave this to the viewers to go and do the mathematics and to show them, to prove it for themselves. And similar things happen in question A and in question C.
Yes.
And my point here really is these are fairly difficult percentage questions, and they're quite good to give your friends as adults and your colleagues in the staff room, because I guarantee you'll get them thinking about mathematics and they'll come asking you for the answers.
Yeah.
And so these are not grade 8 questions.
No.
They are difficult questions, and they're questions that adults struggle with. And so let's not pretend again that percentage is something you've covered and understood in grade 8.
Yeah. Now, I was telling you earlier that I've actually had to remark a batch of tests because I have misunderstood a question like this and marked everyone right because they all misunderstood it in the same way that I did.
Yeah.
It was very easy to...
It's very seductive. It's very, very seductive. So, yeah.
Okay, we're going to move on to the 5-point teaching strategy. And this is a basic idea of what we should be teaching in the next 2 weeks.
Okay, so in grade 10, we've got, as you say, we've got 2 weeks for financial maths. And I know that some teachers want to cut it down because they want to catch up on other stuff. And I appreciate the pressures in grade 10. And given what I've said earlier, I think it's really important to revise percentage and to appreciate that you need to spend time on percentage before you get to simple and compound interest. Then I would go on to the typical textbook examples of simple and compound, with and without the formulae. The curriculum's clear that they should be using the formulae, and I think that's important. But I also think it's important to do some stuff from first principles as well, to kind of remind yourself where this formula has come from.
Okay.
So kind of saying, okay, but I mean, don't choose.
Do you mean
compounding
differential calculus first principles, or?
Yeah, sorry. I'm using first principles like that additive approach or the multiplicative approach, kind of saying, how much, if it's being compounded for 4 years, what's the amount at the end of year 1? How much is accumulated by the end of year 2, at the end of year 3, etc. And so you're doing a year-by-year calculation, and maybe doing that once or twice and using the formula and checking that they give the same answer. But I think often we use, once we've got a formula, we kind of lock into it and we forget where it's come from.
Yes,
and
we do.
Often, when the questions change and you now there's a slight tweak, we don't see it because we can't really remember where this formula came from, and so we use it inappropriately. So for me, it would be about saying, okay, we want to remain flexible and we want to be able to not just compress everything into a formula, but decompress it and go back to where this formula came from.
Okay.
So that's what I'm meaning by first principles and then with or without formulae. Illustrating where the formulae come from, I kind of done an example earlier. That's kind of what I'm meaning. I'm not thinking necessarily of formal derivation. That's the teacher's call to do. My experience is when I've done it at grade 10 level, I've often found the learners kind of, you can see they're not really getting it. And it's actually been more grade 11 where they've kind of grasped it better.
So that's where you establish the compound interest formula using the simple interest formula, or what do you mean by?
Well, the example when I was the example that I had there with the school fees.
Yes.
Kind of looking at what's the amount each year, maybe writing it in the multiplicative, using the multiplicative structure, and seeing how the exponent emerges.
So it's using an example to
It's using an example to prove it, as opposed to using only letters, for example.
Okay.
And I think it's up to teachers to choose something that they think is going to work for the learners. But it's not. This formula didn't come out the sky. It's been derived. There's a logical sequence to it, and I think it's important that learners do get some exposure to that. As I say, when I've tried to do this at grade 10 level, I've often found that many of the learners haven't really got it. So I wouldn't put too much pressure on myself or them to be able to derive it.
Yeah.
And so it might be that you introduce it through an example in grade 10, and then you do it more formally in grade 11, for example, as an example. In that fourth point, where I said practicing but with substituting for all unknowns, in both formulae, we have several unknowns. We've got an interest rate, we've got a principal amount, we've got a time period. And so we can be solving for any one of those. And there are many textbook examples that do that.
Yes.
And I think it's important that learners are having to do that because it gets them to practice changing the subject of the formula, working with different orders of operations, etc., etc. The one thing we must be clear on is that you can't find the exponent in the compound interest formula in grade 10 or 11 because you only learn the necessary mathematics, in other words, logs, in grade 12. And so anything that tries to find the exponent needs to be left till grade 12. And if you look at the curriculum document, it says it very explicitly in the grade 12 document that's kind of where you're coming back to the compound interest formula.
Now, surely you could do it, though, if the exponent was a whole number and it was an obvious answer.
Well, no. It's because you've got to use logs because you're going to be working with, what am I saying? Yeah, you've got to use logs. You can do trial and error, of course.
Okay.
You can use your calculator and say, well, maybe it's 2, maybe it's 3, maybe it's 4, and you can play around with it. But the actual formal stuff, the formal operations, the formal calculation, will need.
I suppose because your base is probably going to be a decimal.
The base is going to be a decimal.
Yeah. It's not going to be possible.
So you're going to get 1 comma something because you've always got that 1 plus the decimal. Yeah. And so that's what makes it difficult. You can't go 2 to the power of 3.
Yes.
For example. Yeah.
Okay, and the last one said linking with grade 10 functions.
And that's kind of what we're going to talk about now. So
yes.
maybe not say any more now.
Okay, so for the next 10 minutes, we're going to look at some very exciting slides and an exciting spreadsheet. So Dylan's going to click onto the next slide. Thank you, Dylan.
Okay.
And SI stands for simple interest.
Yep.
Yes.
And so linear growth, some people talk about linear functions. What I'm trying to do here is to kind of say, what's the connection between simple interest and linear growth, or the linear function as learnt in grade 10? And so if we look on the left-hand side, I've got the familiar formula of y equals mx plus c, which is, we call it the formula for the straight line and stuff like that.
When they're in grade 10, they use the other.
Or they could use ax plus q.
Yes.
Both forms, they have the same form. On the right-hand side, simple interest, that formula, if you remember the curriculum piece that we looked at earlier, had p into 1 plus in.
Yes.
I or r get used for interest rate. I've chosen to use r.
Okay.
But it really doesn't matter. So what I've done in that second line there is simply distributed p. I've applied the distributive law. So I've multiplied p by each term in the brackets. So I get p plus p times r times n.
Right.
Yes.
And now what I want to look at is, well, these two things don't look completely the same. But I want to show how they are the same and how the two connect to each other. Okay. So we're going to take a particular example, and I'm going to illustrate it through this example, which starts on the next slide. So, invested 200 Rand at 10% per annum. It's simple interest, and it's there for 3 years.
Yes.
So I have a table which will come up underneath there. So I've got, in the headings in my table, end of year.
Okay.
And end of year 0 seems a little bit odd.
Yes,
but
it does.
End of year 1 and 2 and 3 probably do make sense.
Okay.
And what I'm trying to do now is kind of also think about timelines which will come up in grade 11. End of year 0 we can treat as the beginning.
Yes.
Okay? So end of year 0 we can treat, if you want, as the beginning of the first year. And then the end of year 1 means it's accumulated 10% interest, which in this case we can see will be 20 Rand. Because we're starting with 200, and at the end of year 2 we have 240. At the end of year 3 we have 260 Rand.
Yes.
So all I'm doing here is a table that's showing what's going on. I'm going to use that now to connect the different elements. So if we go on to the next portion of the slide, we're just coming there.
While Dylan's clicking through, I know when I was teaching this, we'd talk about a child. I would say if a child is 0, it means they're in their first year of existence. At the end of their first year, they turn 1. In the second year of existence, at the end of their second year, they turn 2.
It's quite a hard concept, actually. But, when we say I'm 2 or I'm 15 or whatever, you kind of think it's the beginning of being 15.
Yes.
But it is. But in fact, I've been alive already for 15 years, and it's quite strange to think of it in that way. On the right-hand side, I'm now trying to build towards that y equals mx plus c form. So when x is 0, and I'm treating x as time. Okay. So when x is 0, on the table, I get 200. So if I substitute that into the formula, it doesn't matter what m is at this point. X is 0, so I get y equals... I'm going to get c equals 200 when I substitute 0, 200. That's my y-intercept.
Yes.
Okay. So now I'm going to do a gradient calculation. And so I've taken 2 points in the table. So I simply chose, because I wanted to, the bottom 2 points. And so I've got 260 minus 240. That's my y2 minus y1, if we want. And 3 take away 2 in the denominator, which is x2 minus x1.
Yes.
And that gives me 20.
Okay.
And that's the m. So now, in that last line, I've got y equals 20x plus 200.
Yes.
Okay? And that's a familiar mx plus c or ax plus q form. And now I want to think, okay, but now how does this link to the simple interest formula? And so the next part of the slide, we'll go back there. So we've got P plus PRN, which we had from before.
Yes.
P is the principal amount. It's the 200.
Okay.
R is N is the 3. Okay,
Yes.
let's go to the N because it's 3 years. And the PR is the amount of interest I'm getting every year.
Okay.
We can see that from the table.
Okay.
So even though we don't necessarily think, well, how did PR get there? Well, it's 10% of 200. And so when I add it together, I get the 260, which is what's in the table at the end of the 3rd year.
So the the PR is the principal amount times by the interest rate.
By the interest rate.
Which is 10%. So 200 times by 10% or times by 0.1 gives us 20.
Correct.
Okay.
And so the final link that we can see there is that PR is the same as M.
Okay.
PR is the gradient in the simple interest formula. And it's not that obvious.
Mm.
You kind of think, well, why are there 2 letters here? There's a product, we're multiplying P by R, and we're multiplying N. Now, what's happening? Well, N and X are connected because they're both the independent variable.
Yes.
As we move through time, N is changing, X is changing, and then the PR gives us the gradient.
This almost feels like a good investigation to do with a class. Send them home with homework to figure out what each of the variables within the simple interest formulae represent, or formula. I get confused between the two.
The
yes.
Latin, yeah.
Represents which one within the linear function.
It would be interesting to see what learners can do on their own. I think
Yes.
strong learners will be able to make some of these connections. But I think it's not so straightforward.
Mm.
And so I wouldn't make the assumption that learners can easily do it.
Yeah.
But it would be very interesting to see what they do.
Yeah.
And then to take it from there.
Okay.
So now we wanted to look briefly at a spreadsheet.
Okay,
And-
Dylan, you're going to click across. And the
and to see
spreadsheet will be available online. I'll put the link onto the blog, so you're welcome to go and play with it yourselves. Yes, we're on the right.
So on the
Sheet.
spreadsheet, you'll see at the top we've got 2 numbers in red, the principal amount and the rate, which is an annual rate. And we're assuming here that we're compounding per year. And we've got 200 Rand there. And Dylan, can we change it to 10% just to be easy? And so we'll see there we've got 200,
Oh, magic.
220, 240, 260. It's the same numbers we've just been working with. And there we see the straight line. So that graph is generated by the spreadsheet, and it's simply plotting the pair 0, 200, 1, 220, 2, 240, etc.
Okay.
Okay, and all those things produce a straight line. So if we change the principal amount,
To 300.
what's going to happen?
So the gradient has stayed the same.
The gradient hasn't changed. What's happened is that we now have a y-intercept of 300, which is the P. And if we think what we had before, P plus PRN, it's the P. And N is 0 at the beginning, and so that's where the 300 is. So if we changed it to 400, notice the y-intercept is changing. It might seem like the whole graph is also becoming steeper, but in fact it's not. It's an optical illusion of how there it looks like the graph is getting shorter.
Yes.
So this is some of the things we have when you work with technology. But let's play around a bit with the interest rate. So we're back now to
200.
210%. So Dylan, choose a number.
12%.
Okay, so Dylan's chosen 12, and you can see quite nicely there that nothing happened on the y-axis. It stayed
Yes.
the same, but you saw it becoming steeper. And that makes sense. The more interest we get, the faster it will grow.
Yeah.
And so it links, there's the connection with gradient. How
Okay.
much it grows by is the percentage multiplied by the principal. And so as we choose higher numbers, we'll get it to grow faster and be steeper.
We are very quickly running out of time. So shall we move on to your compound interest slide?
Let's take a look.
Do you want to go straight to the spreadsheet or the slide?
I think let's just stick with the spreadsheet for now
Okay.
in the interest of time. So in this compound interest spreadsheet, we have the exact same design. So the principal is top number. The rate there is also a per annum rate. And as you can see, the same kind of thing is happening. But the shape of the curve kind of shows us that it's exponential.
Yes.
Grade 10 learners have seen exponential functions. Although they can't see anything in quadrant 2, if you want, and it
Yes.
doesn't make sense to talk about quadrant 2
No,
in
it
terms of
doesn't.
time, they will recognize, I think, that in terms of grade 10, this is either half a parabola or it's an exponential.
Yes.
And I think we can convince them pretty quickly this is not half a parabola.
Yes.
And so, again, as we play with the numbers and as we substitute different numbers for the principal, it will have the exact same kind of effect on the graph in terms of the way it changes the shape. Okay. Now, in changing the principal there, we're starting with the higher amount, and so it's going to be the y-intercept moved. Mm-hmm. Everything else is going to move up as well.
Yes.
Because there's a multiplicative thing going on here, and
yes.
we don't have time to get into the details. But Dylan, let's just be a bit radical with the interest rate, and let's see.
Changing it to 20%.
Oh my goodness, he blew it up. Actually, he didn't. We just can't see it.
Down to 17.
Okay. And let's maybe go down to 15. Okay, so what's happening here is that it's growing more slowly, and the visual effect that it looks like on the graph is that there's something that suggests to us that the graph is flatter.
Yes.
Okay, it doesn't grow as steep. It doesn't move as it isn't as steep. And if we can so there we go. That's a great example, because now we've got a really small interest rate, which actually is more typical of what you'd get on a savings account, right?
Yes, I think
which
mine
shows
is
you it grows.
4.4.
It kind of looks a little bit straight, It's after quite a long period, it hasn't grown very much, which shows you the impact of the interest rate. So if the interest rate is really small, even if you've got a fairly big principal amount, it doesn't grow very fast. And 1% can make a substantial difference. So when we hear on the news that the repo rate and another of the bank's rates has changed by 1% or even 0.5%, it can make a substantial amount of difference, depending on the size of the home loan, the size of the car loan. And those are things that are important to realize. Dylan, can you just unhide rows D and I think columns? There we go. So what I wanted to point out here is that we can see that the interest is different.
Yes.
As you go down that column, the interest is different,
and we know that. So that's the amount of interest that's added.
The amount of interest. And it's important here to distinguish that's the interest, not the interest rate. Interest is money. Interest rate is a percentage.
Okay.
And that's the issue of compounding. It's always growing on the latest balance. And so each time the whole that we calculate the percentage of has got bigger.
Yeah.
Maybe not by a big amount, but it gets bigger as we go. But in the final column, we've got 1 point, I'm afraid I can't read it from here.
1.05.
1.05. And that's connected to the fact that we have a 5% interest rate.
Yes.
So if I take let's say row, the amount in the second row at the end of year 1 and divide it by the 500, I get 1.05.
Okay.
That's the bracket. That's the factor that we were multiplying 500 by to get the second amount.
Okay.
And each year we're doing that again and again. And that's why in each row there we have the same amount.
Okay. And your last sheet compares simple, or the third tab there, yes, compares the simple and compound interest.
So what we've
graphs.
got there is 4 columns. I think we need to slide it over slightly. Oh no, we can see them all. So the orange columns relate to the orange graph, and that's simple. The blue columns relate to the blue graph, which is compound. And there's 4 places there where you can enter an amount. And just to say, when people do play with the spreadsheets, only change the top numbers, don't change the numbers inside the columns.
Yes.
Everything is built on whatever's going on at the top. And here we can investigate different things by choosing different interest rates and seeing what happens and seeing where the graphs intersect. And I'll leave that for teachers and their learners to.
Yes. You know what, this is really useful, and it's not so much the teaching but assessing. If you're trying to set up a question where you want to find out which investment or where one investment outperforms another investment, to have this graph to look at and play with the numbers before you set your question is.
And the numbers will because you don't. You're right, because you don't want a question where the answer is so obvious.
Yes.
That there's no point doing the calculation.
Yes. So
Good point.
there we go. Thank you for drawing up that tool for us.
Pleasure. I hope that teachers use it, and please feel free to distribute it to your learners, your colleagues, whoever you like.
Okay, it is 4:00. Are there any parting remarks you want to make at this point? Is there a slide of particular importance that you want to look at? before we say goodbye?
I don't think so. As there are slides that we haven't got to.
Yes.
In terms of illustrating the connection between compound growth and exponential growth. That slide is there, and teachers can take a look.
I'll
and
put
I'm sure
it in
we
the
can
blog.
we can communicate online if necessary, if there's some things that need clarification. But the idea is exactly the same, trying to show how compound interest and exponential growth are connected. It's not quite as easy as the simple and linear, but nevertheless it's there.
Yeah.
And hopefully it's useful for teachers. And for their learners.
Yes. Well, thank you for joining us, Craig.
Pleasure.
Thank you to Dylan for pushing all the buttons at the right time. And remember that if you have an exciting resource that you want to share with us, please do. And you could stand in line to win a phone or a tablet, and they are very nice. So it's worth putting the time in to contact us. Go to the digitalclassrooms.co.za/webinars page for more details. Or you could send your entries straight to us at competitions@digitalclassroom.co.za. Thank you for joining us. Next week we're talking about grade 11 Euclidean geometry. Good times. Join us then. Bye.